For those of you that like to hear an explanation, I am going to make a quick video for you. I hope it's quick. You can hear tech ed in the back, so I apologize. This first one, power of a power, you add the exponents. So 5 plus 1 is 6, plus 7 is 13. The base stays the same. Remember, for 2, this line means division. So when you are dividing, you subtract. So 7 minus a negative 3 is 10, so x to the 10th. For rational or fraction exponents, remember the denominator goes in the front, the numerator in the back. Since it's 1, I don't have to have that. And what it means is what number, when you take it as a factor 3 times, equals 64. So because 4 times 4 is 16, times 4 is 64, the cube root of 64 is 4. For 4, I set it up as an equation. We know that when we're dividing powers with the same base, you subtract. So x minus 3 is 10, so x has to be 13. For 5, I'm going to blow this up a little bit. Remember that whatever is behind is the numerator, in front is the denominator. So here is my fraction exponent. And then power of a power, you just multiply. So 14 times 3/7 is 6. 7 times 3/7 is 3. The reason being, for those of you that don't remember your fraction rules, we can put 14 over 1. 7 goes into 7 once. 7 goes into 14 2 times. 2 times 3 is 6. So that's why it's 6. So really this was more about power of power than fraction exponents. 6 is testing to see if you remember that the exponent goes with whatever is right in front of it, not everything in front of it, just whatever's right in front of it. So here my x has a negative exponent, so we have to bring that up, but the 5 and the y stays down. And 7, that 0 exponent, 0 goes to everything right in front of it. So since this is in parentheses, it goes to everything. So that changes it to 1. So you just have to do, that's over 1, you have to do negative 3 to the negative third power. If it was negative 3 to the third power, it would be negative 27. But because it's to the negative third power, we have to do the reciprocal and put it over 1. The people that I helped with 8, I said if you had 4x to the 4th or to the 5th, let's say, over 2x to the 3rd, how would you simplify that? Well, 4 over 2 is 2 in the numerator, and then you subtract, so we have x squared. It's the same thing, even though there are fractions in there. 9 over 3 is 3. A to the 7/8 over a to the 3/8. If you're dividing powers with the same base, you subtract to get 4/8, and then you can simplify that. So it might look complicated, but really this is a pretty basic problem. As I said in class, I want you to do one thing at a time to make it simple. Don't get overwhelmed. So I did my numbers first. 7/14 can reduce to 1/2. A to the 4th over a to the negative 1. I can bring this factor up. This is 1 over b to the 7th, so that stays down. And then c, this c has negative factors, so I'm going to bring it down. So now I have 10 factors of c in the denominator, and I still have my negative 3 out here. So I'm going to flip it. So this is going to be my numerator, this is going to be my denominator, but I'm going to take it to the power of 3. So 2 cubed is 8, b to the 7th to the 3rd power, I have to multiply my exponents and multiply my exponents. A to the 5th to the 3rd power is a to the 15th. And again, I flipped it because of that negative exponent. And this one looks complicated, but again, do one thing at a time. So I took my power of a power here, power of a product, to make this x to the 5th over x to the 10th, and I just rewrote this. And then I simplified this, so I had to bring my 6 factors of y up to the numerator to have y to the 14th, and I simplified x squared over x to the 7th, so I had 5 factors of x down below. And then this one I could simplify further. I had y to the 10th over y to the 11th, so that left me with 1y. X to the 5th over x to the 10th, so that left me with 5 factors of x for this one. So this is this. Here there wasn't anything to simplify, so I just rewrote it. And then I did x to the 5th times x to the 5th, multiplying powers with the same base, I added. But I noticed I had a y here and a y to the 14th here, so this y could cancel out one of these factors of y to have y to the 13th. All right, starting scientific notation, remember negative exponents, it's a very small number. You're just moving the decimal, the number of places. Big numbers, again, you're moving that decimal, or you're getting the exponent by how many places you have to move. The number has to be, if it's scientific notation, remember the number has to be greater than or equal to 1, but less than 10. It cannot be 10. It has to be less than 10. I'm going to concentrate on 13 and 15 and then move over. For this one, I multiplied 10 times 5 to get 10. And when I'm multiplying powers with the same base, I add the exponent, so 4 plus negative 12 is negative 8. I had to move my decimal one place this way, so I made it 1 smaller, so I had to make my exponent 1 bigger. So negative 8 plus 1 is negative 7. And here, I'm going to do this part first. You don't have to, you could do this if you wanted to, but I'm going to do 5 times 4 is 20. If I'm multiplying powers with the same base, I add the exponent. And then I just rewrote this down here. 20 divided by 2 is 10. If I'm dividing powers with the same base, I subtract. So 4 plus a negative 2 is 6. This is not in scientific notation because it has to be less than 10. So I had to make my number 1 smaller. So I had to make my exponent 1 bigger. So that's my answer. I saw a couple of you do this a different way, and it was very unique. You changed this so it had a third, so you changed this first to be 21 to make that division easier. I'm going to explain it like this, though. 7 goes into 2.1 0.3 times. 4 minus a negative 3 is 7. So 4 minus a negative 3 is 7. This is not in scientific notation because this number is not between 1 and 10. So I had to move it one place, so I had to make it 1 bigger. So because I made this number 1 bigger, I had to make it 1 smaller here. All right, not every single word problem is about distance equals rate times time, by the way. Some of you had that on your formative. You just wrote D equals RT on all of them. But this one does have to do with distance, rate, and time. You were given the distance, and you were given the rate. You were trying to find the time, so it was a division problem. Some of you questioned, well, 2 can't go into 9.3. It can. You have to write it out. If you can't do it in your head, write it out, 9.3 divided by 2, and do it that way. So actually do that long division. So it comes out to 4.65. Dividing powers with the same base, you subtract. So this is your answer, and because it is in, it's an application problem, we want a label, and because we're talking time, it would be seconds. Seconds. All right, yes, I know I have a little typo over here. The mass of a gidget is this. So this is how much one weighs. If there is a crate that weighs this much, how many gidgets are in one? Again, you can make this an easier problem. If one marker weighs 4 and a box of them weighs 16, how many are in the box? So it is a division problem. So I took my larger number, put it in the numerator. In the denominator, 4 goes into 1.6, 0.4 times, and then I'm dividing powers with the same base, so I have to subtract. 4 minus a negative 5 is 9. It is not in scientific notation, so I had to make move my decimal one place greater, so I have to make my exponent one smaller. So this is my answer, and because it is an application problem, we need a label, and we're talking about how many digits there are, so it would be 4 times 10 to the 8th digits.